Hello everyone, my name is Mohammad Firdaus. So today I am going to present to you my analysis of the malware using basic static analysis. Now before I start analyzing the malware, it is important that I obtain some information about the malware itself. To obtain information about the malware, I will scan the file using an antivirus scanner. Antivirus scanner is used to identify suspicious code, analyze the file's behavior, as well as to carry out pattern matching. The antivirus scanner that I'll be using is VirusTotal, which scans and analyzes suspicious files using different AV engines, and it can also generate a report. So I will now use the antivirus scanner to generate a report about the malware. So I will open up antivirus scanner, choose the malware, and I will scan it. As shown here, the antivirus scanner will detect this malware to be a Trojan, a set crack Trojan to be precise. Next, I will move on to hashing. Hashing is a common way of fingerprinting a malware. It is unique and one-way function, and is also produced using a special tool or algorithm. Windows MD5 is the tool that I'll be using here to generate the hash value of the malware. So I will open up the WinMD5 application, and I will open up the malware to generate the hash value. And as you can see here, the hash value is DD37 etc. all the way until AA. Now I will start analyzing the malware using the tools stated here, which is PID, PEView, Dependency Walker, and Bintex. PID. So the PID will be the first tool that I'll be using. So malware authors often pack their malware. Why? Basically, they want to hide its true intentions or contents, and they want to make it hard for the malware examiner to analyze the malware. PID can also be used to determine if the malware is packed or unpacked, and it can be used to determine the language used to write the malware. So I will now use PID to check if the malware is packed or unpacked, as well as to see the language used to write the malware. As you can see here, the malware is unpacked because it is written in Bolan C++ language, which is basically a C and C++ programming environment for MS-DOS and Microsoft Windows. It was actually the successor to Turbo C++ and included a better debugger, which was called the Turbo Debugger, which was written in protected mode TOS. To gather information about the malware, I'll be using the other three tools stated. The first tool that I'll be using is PEView. PEView provides a fast way to view the structure and content of a file. The date and time in which the malware was created and compiled can also be determined. So I'll now use PEView to determine when the malware was created. Under image anti-headers, image file header, as you can see here, it's actually a ridiculous date because the malware was created in the future. The malware was actually created on the 6th of April 2048 on the Monday 3:42 p.m., which is really weird. Next, I'll be using Dependency Walker. Dependency Walker is a free utility that scans any 32-bit or 64-bit Windows module, for example .exe, .dll, etc. It also lists all the imported and exported functions. So now I'll be using Dependency Walker to further analyze the malware. Open the malware. So the malware imports 6 DLLs: ADVAPI32, kernel32, COMCTLL32, GDI32, user32, and OLEAUT32. So first I will analyze the ADVAPI32.dll. And as you can see, this DLL imports three suspicious functions, which is req_close_key, req_open_key, req_query_value. req_close_key basically closes the handle to the specified registry key. req_open_key is a handle that opens the specified registry key. req_query_value basically retrieves the data and type for the specified value name that is associated with an open registry. So now I'll look at the kernel32.dll. And as you can see, it imports some suspicious file like create files, which basically means it creates or opens a file or input output device. Plus, it also returns a handle that can be used in order to access the file or the device. Other suspicious functions will be initialize critical section, which initializes a critical section object, and lock resource, which retrieves a pointer to the specified resource in the memory. Next, I will look at comctl32.dll on the kernel 32.dll. Some of the imported suspicious functions is, as you can see here, get system info, which basically to retrieve information about the current system. Then there is query performance counter, which retrieves the current value of the performance counter, which is a high resolution timestamp that can be used for time interval measurements. And lastly, sleep, which basically suspends the execution of the current thread until the timeout interval elapses. Next, I will be looking at GDI32.dll. Under ntdll.dll, some of the important functions is ntconnect port, which basically means that the malware might be trying to establish a connection with a port, and it also an anti-register thread terminate port, which executes the thread before terminating the port, so indicates that the malware might be trying to make a connection to the malware author possible. Next, I will look at user32.dll under POWRPROF.dll. Some of the imported functions is set active power scheme, read power scheme, get active power scheme. So therefore, this gives us an idea that the malware is trying to tamper with the power scheme of the operating system in order to have complete control of it. For example, get active power scheme here basically retrieves the index of the active power scheme. Lastly, I will look at OLEAUT32.dll, and some of the suspicious functions is sys string len, which basically means that it returns the length of a BTSR, and BTSR is actually associated with Trojan. And as I shown earlier in using VirusTotal, VirusTotal actually detected this malware to be a Trojan. So the final tool that I'll be using is bintext. Bintext is basically used to extract useful strings and files available in any file, for example APIs, application programming interfaces. So I will now use bintext to open the malware and see some of these suspicious functions. And as you can see, the malware imports many suspicious functions. For example, control TV control T control, which basically indicates that the malware might be trying to take control of the operating system. And then there's other suspicious functions that it imports here, which is quite a lot. Some of it is here, get the file attributes, loading resources, locking resources, initializing critical sections, terminating threads, reading files, writing files, and many more. If I keep on scrolling down, as you can see, malware imports many suspicious functions, like install successfully, your computer has been and basically get system menu, get Windows, loading strings, loading cursors, setting the timer, may possibly set timer for it to perform its functions, waiting message, which might indicate that the malware might be waiting for a message from, let's say, a malware author. So basically, this is what I found out about the malware by using the basic static analysis techniques.